All right, so in this lesson, we're going to talk about simplifying radicals, but now we're going to add variables to that equation. So let's take a look at how this works. So our goal is to be able to simplify radicals now with variables. All right, so again, you have a perfect squares, cubes, and fourths sheet. This one, I just cropped it out to up to 10, but yours goes up to 15. I would strongly encourage you to have that, maybe even attach it to your assignment and just use it so you can flip back and forth and see what's going on. Okay, so radicals with variables, how does this work? So now when you see variables in here, you really want, anytime you're dealing with square roots, you want your exponents, right, the powers, to be multiples of 2. Okay, I'm going to do a bright color here. Multiples of 2. So like 2, 4, 6, 8, you want multiples of 2. If it's a cube root, as you might guess, you want multiples of 3. Powers of 3. And if it's a fourth root, you want multiples of 4 for your exponents. Okay, so when I'm saying that, we're talking about, remember when we simplify, we always break it into a perfect square or a perfect cube or a perfect fourth, and then the other part and what's left over. So that's still going to happen here. So I want to, first you're going to start by I like to start by just putting my two radicals. This is your perfect square part, and this is the leftover, okay? So now, we want to, let's start with the number, 32. So we want to say 32, let's look at our chart here, okay? And we're looking at squares, so 32. Well, what's the biggest, or what's the, perfect squares that go in? You know that 16 goes into 32, and so does 4. You want the biggest ones, we're going to use 16, right? That's a perfect square. If I take the square root of 16, I get 4. Okay, so that's all the stuff we want to use. So that's how you use the chart, or you can use your calculator to do that, whatever works best for you, or a combination of both is usually the most effective oftentimes. Okay, so here we're going to put our perfect squares. 16 goes in here. Might have to extend this a little bit. Now, this is a square root, so we want multiples for our powers of 2. So I want the biggest multiple that I have here of 2. Now, it says x to the fourth. Well, that's a multiple of 2, so I can put the whole thing right here. Okay, now we're going to do y. So y to the 9th. Well, I can only put all the highest multiple of 2 that will work here under my perfect square. So that would be y to the 8th. Okay. So I can put 8 of those here. That means I have 1 left over. So now let's go back over here. Maybe 16. That means I have 2 here. Maybe we'd do that right away instead of doing it the way I did. I don't know. And then I have x to the fourth. Well, that's all of them, so I won't have any x in this other one. And I got y to the 8th. So that means I have 1 left over. So I'm going to put y to the first, or just y. Okay. So this, again, is my perfect square part, okay? So now I'm going to simplify that. The square root of 16 is 4. X to the fourth, take the square root of that, you get x squared. Basically, you divide by 2, right? Because this is really the index is 2, so you're going to go 4 divided by 2. So then this would be y to the fourth, okay? And then I'm going to write what I have left over that I can't do anything with. So this would be times the square root of 2y. And now you've just simplified your first radical with variables. Okay, so hopefully that makes some sense. Let's try one that's a little bit different, a little bit sneakier. All right, so this one says the square root of 324. A to the third, b to the 7th. We're going to simplify this. So again, start perfect square part, the leftover part. Okay, now 324, if you look at your chart, squares, notice this one doesn't go up. Even if you use your 15 one, it only goes up to 225. So what I would suggest when you get numbers that are bigger than on your chart is use your calculator to see if it's a perfect square first. and then just divide by perfect square. So let's do the square root of 324. Is that a perfect square? And it is. Okay, so that means the whole number there I can put underneath that first radical. So that's what I'm going to do. 324. That means I don't have anything left over to put over on that side, so I'm good. Okay, now it's a square root, so I want to put the highest multiple that I can of a to the third. That would be a squared. And then that means I have 1a left over here, so I think I'll write it right now. And then I have b to the 7th, so highest multiple of 2 that I can do would be b to the 6th. That means I've got 1b left over here. Okay, now I can simplify. The square root of 324 we just typed in, we got 18. A squared, take the square root of that, we get a to the first, or a. B to the 6th, take the square root of that, we get b to the 3rd. And then I write what I have left, times the square root of ab. And there, we just simplified. Okay, so there's some squares there, square roots. Hopefully that makes sense. Let's try some cube roots. All right, as we said, and you might guess, with cube roots, you want multiples of 3, okay? So let's look at this one. We got 216, cube root of 216, m to the 3rd, n to the 6th, and cube root of negative 81, p squared, q to the 12th. All right, so here, let's break this apart. Cube root. Don't forget to put your index in there. All right, 216. Now, if we go back up to we're doing cubes here. 216 is already a perfect cube, so cool. All right, so that means I got 216 right here. And then multiples of 3 now. So m to the 3rd, that whole thing can go here. And then n to the 6th, that whole thing can go here. So that means I don't have anything in this spot. This whole thing is a perfect cube. So the cube root of 216 is 8. Cube root of m cubed would be m. And cube root of n to the 6th would be n squared. Again, you're going to take the exponent and divide by the index. Okay? So that's how I got that. And that's my answer. Notice there's no radical in this. This is a perfect cube. Okay. Now this other one, let's look at this one. Same thing. I'm going to start out by just doing my perfect cube and the leftover stuff. Okay. Now 81, is that a perfect cube? Let's look. Okay. No. So let's see, the biggest number that would go into 81 would be 27. So again, use your calculator if you're not sure. So that's what I want to use there. Now, one thing that I noticed on your assignment, whenever you have cubes and there's a negative, you want to take that negative into the perfect cube part. So this should be negative 27 here. The cube root of negative 27 is going to give us negative 3, right? So make sure that negative goes with their perfect cube part. Okay, so that means what do I have left over? Over here, that's going to be a 3, because negative 27 times 3 gives me negative 81. All right, let's do our p squared. Well, that is not a multiple of 3. It is already below that, so all of those are going to go over here in that part. Okay, and then multiple q to the 12th, well, that's a multiple of 3. I can put that whole thing over here. So perfect cube part, left over. Okay, now you're going to simplify the perfect cube part. So this would give me negative 3 q to the 4th, and then times the cube root of 3p squared. Okay? Make sure always when you write this too, it's a little smaller and in that spot so you don't get confused with that. Okay. All right. Hope this is starting to make some sense to you. I want to do some force, and then that's it. All right. So let's take a look at this one. So this is the fourth root of 48x to the 8th, y to the 3rd. So once again, we'll start. Okay, now 48, if we go back, look at our chart here. Now we're looking in force, right? So 48, well, already I'm here, or smaller. 16 goes into 48. So that's what I want to use to break that apart. So let's do that. Okay, so the perfect cube part here, I would have 16 here, and then that would be 3 left over here. 16 times 3 is 48. And then multiples of 4, so this would be x to the 8th, that whole thing could go here. Y to the 3rd, that's not a multiple of 4, so this whole thing has got to go over here. All right, now we're going to simplify. So be careful here, this is the fourth root of 16. Don't put 4 here, this is not 4, right? We're doing fourth root. So this should be 2x squared, right? 8 divided by 4 is 2. And then what I have left over, 3y to the 3rd. Okay, that's a 4. It's kind of an ugly 4, but you get it. Okay. All right, let's take a look at this one. Okay, notice there's no number here. So I can just break apart. Okay, w to the 4th goes here. V to the 16th goes there. That would be the highest multiple of 4, and that means I have 1 v left over here. So now if I simplify this, this would be w to the 1st power v to the 4th times the 4th root of v. And that's my answer. Okay. All right, here's a couple other problems we can look over. And I put the answers on those in case you were looking for some other ones, just to be sure you understand how this works. That's it. Don't forget to write into your assignment book. This is Simplifying Radicals with Variables worksheet. And come in to Ask the Teacher time if you get stuck on anything. Good luck.